so now we're going to get into chapter 13.3. Now, we're not going to see box plots on this one, so please don't get comfortable and just think, I can just forget all that information. You can't forget about it. We're going to do box plots on the very next lesson. You're going to do box plots on your mid-chapter checkpoint. You're going to do box plots for the rest of chapter 13, and then we're going to review them again as we finish up this school year in this 9 weeks. Box plots is going to be shown on your NWEA. It's going to be on your next I-step. So it's something you need to understand. You're also going to be doing them in 7th and 8th grade, probably even your freshman year. So when we talk about this lesson, though, this is something we've already looked at and we had a brief introduction to. Once again, none of these lessons have been difficult math steps. It's just remembering all the steps. And if you follow along like I asked you on yesterday's video, I know yesterday's video was long, but it was a lot of information because it was all brand new. This one shouldn't be as long, but it's still a lot of steps that we have to remember. If you're following along and filling out your book and taking the notes that I asked you to, you're going to get this without a problem. So just please pay attention, follow along, and be active in what you're doing. So the mean absolute deviation looks like this. We're talking about, in this scenario, magazine subscriptions is being sold by the drama club to raise money. And we are going to have two different teams that we're going to look at and compare their information. Here's how many one team sold. Here's how many the other team sold. But we're going to be using the mean every time. So when we use the mean every time, if we look back in our book at chapter 12.5, we'll see we were introduced to this in a previous lesson. So in 12.5, we talked about this scenario, finding out what the distance was from the mean for each number in our data that we collected. And that's what these math problems were for that I had you write down if you followed along. We went to the mean every time, which we said was 3, and we subtracted the distance from each of the data points. Or then we subtracted from the data point, if it was larger, the mean itself. That's what this whole lesson is actually about. So let's look at A and see where our numbers come from as we're building the data information to do the final math. So I look at team A. Well, I have to know what my mean value is. They're showing you if I go one step from the 4, that's equal to a mean of 1. Well, what that is I'm taking this information up here where it tells me what each of those points are. So I have a 3, I have a 3, and I plot those. And then I have a 4, so I plot it. And then I have a 5, and I have a 5, so I plot those. So I have 1, 2, 3, 4, 5 on team A. 1, 2, 3, 4, 5 blue points. I know I have it shown. Well then, where does my deviation come into play? My deviation just means a change of, going away from center or the norm. So when I go up here then, and I see that it tells me that my mean number of subscriptions for each team is 4, it's just saying the average value that the people sold in each of the teams is 4. So let's see what the deviation is, the changes, how spread out the entire group actually is from the average or from the mean, which is 4. So each time I'm going to go from my mean and I'm going to subtract if it's a smaller value. Or if it's a larger value, I'll start with the larger value and subtract the mean from it. So in my first comparison, I have the mean of 4, and that's where I'm going to go back to every time. And I'm going to subtract my 3. And when I take 4 minus 3, I get 1. That's where this 1 came from down here that's already in your book. But then I have to go point by point. Here's another 3. So 4 minus 3 again is still another 1. And then I go back to my 4, and this time I have a 4 on my dot plot. So 4 minus 4 is a 0. Well, I have to mark that it's a 0 because that affects how many numbers that I'm using in my math. And then I have a 5. Well, I can't take 4 from 5 or 5 from 4, so I just switch it and I do my 5 first and subtract my 4 instead. So 5 minus 4 is a 1. And then another 5 minus 4 is a 1. So this shows me my deviation, my change from the average, my change from the mean for each number or each data point that's collected here. I add my totals together. 1 plus 1 plus 1 plus 1 is 4, and I have 4/5 because I have 5 pieces of information. When I make that into a decimal then, I put my numerator inside the division box, divide by the denominator. We're going to be reviewing all those lessons as well here in a couple weeks. But I take 4 divided by 5 and I get 0.8 or 8/10. So I know my mean deviation from this group here is 8/10. So that is just called my mean average deviation because I'm taking my mean, I'm averaging them together in the process of adding them all for a total, dividing by how many is there. That's why it's called the mean average deviation. So then I'm going to go to my second group and we'll look at Team B. So if I keep the information from Team A on there, now I do the same thing with Team B. What numbers am I using? Well, I'm using the Team B, which is this group here, but I'm still going to go back to the fact that they both teams have a mean or an average of 4 that they're selling. So I go and I start plotting. I had somebody that didn't sell any, not a real big team supporter there. I have 1, I have 4, I have a 7, and I have an 8. Then I come back to the mean, and I'm going to do my subtraction every time. I have a 4 and a 0. So I take my 4 minus 0 and I get 4 and I write it down in my numerator. And then my next number is a 1. So 4 minus 1. 4 minus 1 is 3. Once again, none of these are difficult math problems. It's just basic math that we're doing. It's just remembering all the steps to collect the information in what order it goes in. My next one is a 4, so I have another 4 minus 4 is 0, like I had on the previous lesson, or the previous set. Then I have a 7. Once again, if I have 4, I can't take 7 away from it because we're not talking about integers in this lesson. So I have to just put 7 on top, and 7 minus the 4 then is going to be 3. That goes in my numerator. And then 8 minus 4. 8 minus 4 is 4. So I've collected all of those pieces. How many people were on Team B? Well, Team B had 1, 2, 3, 4, 5 people on the team. When I look at the total in my numerator then, 4 plus 3, well, that's 7, plus 3, that's 10, plus 4, that's 14. And I keep my denominator of 5. So 14 over 5. Once again, I'm going to divide just like I did with that one. Numerator goes inside the box, divided by my denominator. It's going to be a decimal, just like the first one. So when I put the 14 inside the box, I add my decimal, I add my 0. I divide by 5. That's when I can pick up my handy-dandy calculator, type it in, 14 divided by 5, because I have to type in the number that's inside the division box first. That gives me an answer of 2.8. Once again, what I just did is I found the mean average deviation, the average amount of change from the mean of the group. So now with that information then, I have to look at what the next question asks below. I've done the work, now I have to think about what the work is telling me. Which data set, is it Team A or B, looks more spread out in your data plots? So when I look at just the data plots, Team A is here, crunched together. Team B is all spread out from 0 to 8. So between 3 and 5 and 0 to 8, well, that Team B is more spread out. Well, then it says, well, which data set had the greater average distance from the mean, and explain how those two facts are connected. Well, more spread out is Team B as well. And the more spread out, the greater the average distance. It should make sense that when I say that B is more spread out, that the average distance is going to be greater. Because I know that someone went 4 from the average of 4. And I know that someone went 4 from the average of 4 on both sides. If all I have is going 2 or 1 from the average of 4, they're not as spread out, and therefore my deviation, my change from the average, is not nearly as great. So that's all this lesson is about. Follow along. We're going to continue and work through these. Now, I'm not going to show the subtraction problems every single time, but I'm going to show you where they come from as we fill it out. But if I go too fast, please pause the video for a brief moment, fill out your book, and then continue. So the mean absolute deviation. I just showed you what it means, but now the book is giving you the definition a little later on. It says the mean of the distances of the data values, all the information that's collected on the dot plot, from the mean of the data set. So I have to know what the average number is. Now, so far, what we've seen is they're nice, and they're giving me my mean in all of these scenarios. They're telling you that our mean is 10. On the previous one, they told us the mean for both of those was 4. So I knew where I'm going to get my values. I didn't have to go in, I have to add all of the original data and divide by how many are there. It's not a difficult math problem. It was just an extra step I'd have to do. They're telling me what the mean is. I don't have to worry about it in this problem. So if I know my mean is 10, that's the number I'm going to do my subtraction with on each step. So what do I have first? Well, my first I have an 8. And so I know my math problem would be 10, because that's my mean, minus the 8, minus an 8, minus an 8, minus an 8. Each time I'm going to get 2, correct? Because 10 minus 8 is 2. Well, there are 4 of them. Notice the 4 blue lines in your book. So they're telling me I have to subtract those every time. So all 4 of those are going to be 2's. In the same way, if on my dot plot I have a 9 and my mean is 10, well, 10 minus 9, there's a 1. And then they say, well, there's 3 of them that are 10's, and 10 minus 10, well, that means I have 1, 2, 3 zeros, because 10 minus 10 is 0. If I'm larger than my mean, then I just start once again with that number instead of trying to subtract to get a negative, because we're not dealing with integers in this lesson. 12 minus 10 instead of 10 minus 12. Well, 12 minus 10 is 2, and there are 3 of them, so I know I'd have 12 minus 10 is 2, 12 minus 10 is 2, 12 minus 10 is 2. And then I have a 13. 13 minus 10 is what? Should have been a pretty easy math question. Should have been a 3. So then I have to plug all that in down here. That's what this line is for. So I know it's going to take you a little longer to fill that in than what it did me, because I clicked a button and it happened. Make sure that each of yours are written down. Pause the video for just a moment. Make sure you have that filled out. And understand there are 12 of them, and the 12 came from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data from my scenario. After you have it written down, unpause, we continue forward. So then I know I have to add all of my numerator together. When I add all of my numerator together, 2 plus 2 plus 2 plus 2 plus 1. So this is where your handy dandy calculator comes in, and you hit the number with an addition sign in between until you get to the end. You get an equal 18. Then I keep my denominator of 12 because there's 12 pieces of information. When I take my division, my numerator goes inside my box. I divide by my denominator in my handy dandy calculator. I just have to type in 18 divided by 12 equals, and I get 1.5. So I know my mean absolute deviation, my average from the center point, the mean, is going to be 1.5 years. All right, so how does these two work? Same information, same process. It says find the mean absolute deviation for both data sets. Explain which data set is more spread out. So there are times on your assignments and on your tests, you're going to have 2 things that you're going to compare, and then sometimes it's just going to be solving it by itself. Easy math, just remembering the steps is what you have to do. This is why if I show all of my steps in my book and I go in 2 days to take my mid-chapter checkpoint and I look back in my book, I can get these problems correct because I've showed everything that Mr. Barker has asked me to do. If this is my data points and this is my mean, notice that the mean on both of them is the same. That's how we're able to compare them. Then I know I have to start with where my mean is, subtracting with the data points. So I'm going to take 7 minus 5, that's where the 2 came from. 7 minus 6 is 1. 7 minus 6 is 1. 8 is larger than the 7, so I start with 8 minus 7. 8 minus 7 is 1. And 10 minus 7 is 3. I have how many pieces of information? 1, 2, 3, 4, 5. So my denominator is 5. Add my numerator together. 2 plus 1 plus 1 plus 1 plus 3. That gives me 8. And I keep my denominator 5. 8 goes inside my division box. Divide by 5. Handy dandy calculator. 8 divided by 5 equals. So when I divide them out, I know I get 1.6. So we're saying my deviation with a mean of 7, the average would be 1.6. Now I'm going to look at Laura's swim laps. I know that we have differences here of 1, 3, 7, 11, and 13 from my mean. So their differences are 7 minus 1 is 6, 7 minus 3 is 4, 7 minus 7, that's a 0, but I keep it because I have to have that one included when I do my average. 11 minus 7 is 4, 13 minus 7 is 6. Make sure those are written down. I have 5 pieces of information there in my numerator, so I'm going to divide by 5 because we're still finding the average of them. Then I add them together. 6 and 4 is 10, 4 and 6 is 10, 10 and 10 make 20. So 20 divided by my denominator of 5, top number goes inside the division box, divided by my denominator. My divisor tells me that 5 goes into 20 4 times. So I know my mean absolute value on that one is going to be 4. So then I have to look at my comparisons. If my mean absolute deviation on the first one is 1.6 and on the second one it is 4, the question is asking the data set of blank laps is more spread out because the mean absolute deviation of our data is, so we're talking about being more, has to be greater. Which person has greater, Shauna or Laura? Well, Laura's laps is more spread out because it has a greater deviation. Make sure it's filled out. If it's not, please pause the video because I'm going on. All right, so on this one, I'm not having to compare anything. I'm just solving straightforward problems. What is the mean absolute deviation for this group of data? It tells me, once again, what the mean is. If it wouldn't tell me what the mean is, I would have to add 4, 5, 5, 5, 5, 6, 9, 10, 10, 11, and then divide by how many is there. I don't have to do that. They just tell me right ahead, the mean is 7. Go with that. All right. I like it when they make it easier for me. So now I have to find what my numerator is on that big fraction that we are building. So I go from my mean and I'm going to subtract each of these data points and get a value. Or if it's larger, once again, then I take it and I subtract my mean from it. So I'm going to get 7 minus 4 is 3. 7 minus 5 is 2. Minus 5 is 2. Minus 5 is 2. Minus 5 is 2. 7 minus 6 is 1. Then I go to the 9, it's larger, so I just start with the 9. 9 minus 7 is 2. 10 minus 7 is 3. 10 minus 7 is 3. 11 minus 7 is 4. That's where my numerators come from. What's my denominator? How many data points I have, and there are 10 of them. So I know I'm going to divide by 10. My next step is what? Hopefully you thought. I'm going to add my numerators. If you haven't gotten it written down, pause it, write it down, unpause it, and then add them together to get a numerator of 24. I know I'm dividing by my denominator of 10. In my handy dandy calculator, I just have to type in 24, the top number, divided by 10 equals. But inside my division box, I show 24. Numerator goes on top. Denominator is my divisor. So I have my dividend divided by my divisor, which gives me a quotient of 2.4, 2 and 4 tenths. 2 and 4 tenths what? it tells me I'm talking about books, so 2 4/10 books. The next question has nothing to do with question 2, so I'm not doing a comparison or explaining. I'm just going to solve for the mean absolute deviation of this weight. How did I know it was about weight? Because my dot plot tells me I'm talking about weight in pounds. So I start with looking at it, and I see that it already gives me my mean. I don't have to calculate my mean. I say, thank you, book, for being nice to me. Let's get into the math. I'm going to take my mean, and I'm going to subtract all the smaller ones. Then I'm going to turn around. I'm going to take the larger ones and subtract the mean, getting positive numbers here, not integers. So then I'm going to take 29 minus 26, 3. Minus 26 is 3. Minus 26 is 3. And I have 29 minus 27 is 2. Minus 27 is 2. I have a 32 minus 29 is 3. 33 minus 29 is 4. And then a 35 minus 29 is 6. So my numerator should be 3 plus 3 plus 3 plus 2 plus 2 plus 3 plus 4 plus 6. You get your work point by showing this. I don't need to see you building a basic subtraction problem that you learned in 1st and 2nd grade. I'm fine with you understanding mentally at this age level as a 6th grader that 29 minus 26 is 3. I don't need to see that. This is what I need to see, that you can build your numerator with all the differences and that you're going to divide by 8. Then we can do the math there. When I add them together, I get 26 in my numerator. I'm still dividing by the 8 because there are 8 there. And when I type that into my handy-dandy calculator, I put it inside my division box divided by 8. I know it's a decimal. I know that 8 will not go into 26 evenly. So I would just add a decimal and zeros and raise them up. But in my handy-dandy calculator, it's much easier. I've shown Mr. Barker that I'm going to be dividing, and then I type it in inside my dividend first, divided by, outside, divides it per second, equals quotient 3.25. 3.25 what? Well, as we said at the very beginning, I have 3.25 pounds. Now we look at this. All right, so now I've got information. I have a story problem, and I have to be able to use it to figure out what we're talking about. The mean absolute deviation of the number of daily visits in Scott's website for February is 167.7. So all that's saying is he took all the days in February, added them together, and divided by the 28 if it wasn't a leap year, or 29 if it was a leap year. Well, in March, the absolute mean deviation was 235.9. So we'd find out the distance between the averages, divide by all the days of March. But what it's asking is, in which month did the number of visits of Scott's website vary more? Which one had a more spread out grouping of numbers? Maybe from a 0 to 100 different people visiting. Well, I know that without doing any math. And a lot of us, we get to the point when we read these problems, we're like, well, I don't know because it doesn't show me. I don't have to do it. If we go back to the ones that we just did and we see the comparison, when I know that my deviation is greater, then that means this distance spread out is also going to be greater. I don't have to do any math there. I just have to figure it out by looking at it, and I see that it has to be March. And how do I know it has to be March? Because March is bigger. The larger the deviation, the greater the variance, the greater the distances between in the data points. So I don't have to do math. I just have to be able to read it and understand that when my deviation is larger, then my variance is going to be larger. Variance, once again, is just how spread out my numbers are. I'm going to apply this information down here with the second one. This one says I'm going to write an inequality. So now we've got to reverse our brains and remember what inequalities are. Well, it says in April, the data for Scott's website visits are less spread out than they were in February. Use A to represent the mean absolute deviation for April. Write an inequality to describe the possible values of A. So let's look at everything it's saying. It's saying that we're talking about it being less spread out. Okay. It's talking about using A in place of April. Okay. and I'm going to write an inequality. All right, what's an inequality? Once again, inequalities are using letters and telling me, is it less than, is it greater than, is it less than or equal to, is it greater than or equal to? Well, with that information then, I know I'm going to be talking about April. I know I'm talking about it's less spread out. So I know it's a less than scenario. I know that I'm comparing it to what? Well, I'm comparing it to February. Do I know what February is? I do know what February is, because as I said, we're going to apply this information. I know it's 167.7. So from that information, I'm going to write my inequality. Instead of April, we're going to put an A. Instead of the word less, we're going to put the less than sign, and then we're going to put the value of February. So my inequality that I end up with is A is less than 167 7/10. Should be pretty easy. Shouldn't be difficult at all. In the same way that the few questions that you have on your assignment shouldn't be difficult either. So get into your book, start working on your assignment. If you followed along and you took your notes, it'll help you on your mid-chapter checkpoint in 2 days. It'll also help you on your assignment. If you got lost or you get a question and you're not quite sure what it means, that's when you come and ask, and then I can help.